Okay, so in this video, we're asked to find the surface area of the solid generated by taking the graph of y equals square root of negative x squared plus 6x minus 5, which is this semicircle, but we're only looking between 2 and 3. So basically, we're going to get this solid that's kind of like a spherical, think about it, spherical stand, if you will. That's the best way to think of it, where it's narrower on the top than it is on the bottom. Okay. So that's kind of, and then rounded on the sides, of course, just like a sphere. So that's the solid we're looking at, and again, we're just looking between 2 and 3. So remember, surface area is 2 pi, the integral between your limits, 2 pi function times the arc length. So, of course, for this problem, we're going to need to know then the derivative of that function. So let's compute that. So towards that end, I'm going to rewrite y prime and using a fractional exponent. So that stuff to the 1/2. And then, or not y prime, that's just y, sorry. Now we'll do y prime using the chain rule. That will be the derivative of the outer function. So 1/2 times that stuff. Now to the negative 1/2 times the derivative of the inside. Negative 2x plus 6. Okay. And then we just clean this up and simplify. So the 2 from the 1/2 will cancel with both the negative 2x and the 6. So we'll have negative x plus 3 over this stuff. Now will go to the bottom, become to the 1/2 or square root of negative x squared plus 6x minus 5. And so now we're ready to go in and talk about our integral, and we're going to have a bit of algebra to do here. In fact, let me just be proactive here. The formula again calls for the derivative squared. So let's just go ahead and square y prime. So that's going to be negative x plus 3 times negative x plus 3 will be x squared minus 6x plus 9. And we square that part. And when you square the denominator there, it's just going to be negative x squared plus 6x minus 5. Right, so now we're ready to go into our surface area. So it's going to be 2 pi times the integral from 2 to 3 of my f of x function. So negative x squared plus 6x minus 5 to the 1/2 times the square root of 1 plus that stuff. Over negative x squared plus 6x minus 5. Okay. So of course what we're going to have to do here is simplify this algebraically. So we would need to get a common denominator, which will of course just be my big old denominator there, negative x squared plus 6x minus 5. And that's going to become that stuff over itself. So the 1 will be negative x squared plus 6x minus 5 over itself, and then plus the other one there, x squared minus 6x plus 9. And things work out nice for us now, because notice that our x squareds will now cancel out, and the 6x's will also cancel out, leaving us with just minus 5 plus 9. Minus 5 plus 9. Okay. So, in other words, all the stuff inside just becomes 4 over that denominator. 4 over that denominator, all inside the square root. Okay. So, at this point, we're going to have 4 over negative x squared plus 6x minus 5, all that inside the square root. Okay. Well, then we can apply the square root to both parts. And when I do, I'll get surface area equals 2 pi times the integral from 2 to 3 of negative x squared plus 6x minus 5 to the 1/2 times the square root of 4, which is 2, over the square root of the denominator, or in other words, the denominator raised to the 1/2. That's dx. And the original one should have a dx as well. I forgot to put that down. Okay, so life becomes good. And we literally just have now the integral of dx. So, doing so, we have 4 pi x evaluated between 2 and 3. And so we can now compute the surface area. Right? We plug in 3, we get 12 pi. Plug in 2, we get 8 pi. 12 pi minus 8 pi. Turns out we get 4 pi square units. Now, it was very necessary here that we had something nice. To actually compute a lot of these surface areas directly, we will need something nice that can eventually cancel a lot of stuff out, so that we have an integral that we can actually work with. And that was the case in this problem here. And so for a lot of the ones where you're going to be asked to work them out directly, they're going to need to be set up like that.